Okay, welcome to the next tutorial video. This is on Physics 1, Topic 2, Forces, and it's Part 1. This appears on the first physics paper. Today I'm going to go through Newton's first law, Newton's second law, weight and mass and the difference between them, the core practical, which relates force, acceleration and mass, and finally circular motion. This can be found on pages 172 to 176 in your revision guide. Please watch this as many times before your Friday study club. Newton's first law states that a body will remain at rest or continue in a straight line at a constant speed as long as the forces acting on it are balanced. Let's look at two examples. A stationary object. Here's a ball suspended from a piece of string from a roof. The string applies a tension force on the ball in the up direction with a force of 25 newtons. The weight of the ball always acts down, which has a force also of 25 newtons. Hence the force arrows are the same length, the forces are balanced, therefore the object is not moving, it's stationary. Let's take the example of a car moving at a constant speed. Let's label the force arrows on the car first. This force arrow will be the thrust force from the engine, and this force arrow back here will be the drag, and that would be caused by friction between the car tires and the road and air resistance. These force arrows are the same length, they are balanced. Let's assign numbers. The thrust force arrow 15,000 newtons and the drag arrow is also 15,000 newtons. Therefore, if I was to calculate the resultant force in the horizontal direction, you would subtract both values. 15,000 subtract 15,000 equals 0 newtons. There is no resultant force. This means that the object, which in this case is the car, is moving at a constant speed. Let's finish the force diagram. This force arrow would always be the weight acting down on the car, and the car sits in the road, therefore the opposing force to the weight would be the reaction force caused by the ground. Those force arrows are also balanced. Let's assign numbers. Let's say the reaction force is 10,000 newtons and the weight of the car is also 10,000 newtons. Therefore subtracting both equals also 0 newtons of a resultant force. Therefore the car is stationary in the vertical direction but at a constant speed in the horizontal direction. A little bit more on resultant forces. Let's say we have a box which we apply a push force of 10 newtons this way and a dragging force of 10 newtons is created to the left caused by the friction between the box and the surface of the ground. The resultant force on this box is, you always take the larger number, subtract from the smaller one, which is 5 newtons, and because force is a vector quantity, it has a direction, you must tell us where that extra 5 newtons is applied, which is to the right. Therefore it's got a resultant force of 5 newtons to the right, therefore the box will move towards the right. Some other force diagrams. Let's say a box has got a force of 1200 newtons acting up and 800 newtons acting down. The resultant force on that box is again the larger number. Take away the smaller force, which gives us 400 newtons extra acting up. Therefore the box will accelerate upwards. That is unbalanced forces. One more example. A box has a force of 600 newtons acting up, 800 newtons acting down. The resultant force on this box is 800 take away 600, which is 200 newtons extra acting down. So a resultant force of 200 newtons acting down, therefore the box will accelerate downwards. This leads us on to our next formula, and this formula again, like other ones stated, has to be learnt. F is equal to ma. In other words, force, which is always measured in newtons, equals mass, which must be measured in kilograms, times acceleration. measured in meters per second squared, hence Newton's second law. Put that into a triangle, we should be used to doing that. F goes on top, m times a at the bottom. Therefore, whichever one you need to calculate, the unknown, you always put your finger over it. If we're looking for acceleration, it's F divided by m. If we're looking for mass, it's F divided by a. And of course, if we're looking for force, it's m times a. Let's do a worked example where we use this formula. The diagram shows a horizontal force acting on the boat. The boat has a mass of 400 kilograms, so that's its mass, m. Calculate the acceleration of the boat. Now there's a little bit of a sub-calculation to do with this first to work out the force. So we are asked to get the acceleration. So in other words, acceleration equals force divided by mass. So always write the formula first. A equals force divided by mass. My mass is 400 kilograms, but I need to do a little calculation first to get the force. So I work out the resultant force. If there's 900 newtons thrust acting to the right, 600 newtons drag acting to the left, the resultant force of that, quite simply, is, again, take the larger number, subtract it from the smaller number, which is 300 newtons acting to the right. So my force is 300. So sub in my values to my formula. 300 divided by the mass in the question, which is 400 kilograms. Do that in my calculator. 300 divided by 400 equals 0.75, and I never give an answer to a calculation without a unit. Acceleration's unit is meters per second squared. The last new term we're going to introduce to you, this is only on the higher tier papers, which is inertial mass. Inertial mass is a measure of how difficult it is for an object to change its velocity. So therefore, if it has a larger mass, it's going to need a greater force to accelerate it. If it has a lower mass, the object will need a smaller force to accelerate the object, hence defined as inertial mass, the measure of how difficult it is to change its velocity. So much larger objects with a greater mass, they'll need a greater force to accelerate, and obviously the opposite is true also. Now on to weight and mass and the difference between them. Let's start with mass. Mass is just simply the measure of how much matter is in an object. When you measure your mass on the scales and you get something like 60 kilograms, that's how much matter is in your body. It's a scalar quantity, which simply means it only has got a size, not a direction. And the units which we've mentioned before are in kilograms. Weight, though, is a force. And the force is caused by the force of gravity pulling on an object's mass, which is its weight. The gravitational force pulling on a mass, which is an object's weight. Therefore, it's a force, which means all forces are vector quantities and measured in newtons. And a vector quantity, as you know, has got a size and a direction. There is a formula that relates weight, mass. And it's this formula, again, the second one in this topic that you need to learn. Weight equals mass, measured in kilograms, times gravitational field strength, which is always a constant value on Earth, which is a value of 10 that you need to remember. If it's a different planet, the question would always state what G is. However, on Earth, you need to remember it's 10. Put this formula again into a triangle. W, weight, goes on top, mass times gravitational field strength on the bottom. And like I said previously, whichever variable you have to calculate, you cover with your finger and you know what to do with the rest of them. Let's do a worked example. Calculate the value of G on the surface of a planet where a mass of 18 kilograms experiences a weight of 54 newtons. So that's my mass, and it has the correct unit, kilograms. That's my weight, and again it's got its correct unit, newtons, for force. Therefore I'm looking for G. Therefore I cover G, and I can clearly see from my triangle that it's weight divided by mass. So write that formula. G equals weight divided by mass. That will be a mark straight away. Sub in my values. Weight is 54 divided by the mass, which is 18. Therefore do that on your calculator. 54 divided by 18 gives you 3. Now again, you always attach a unit. So what are the units of G, gravitational field strength? Well, G equals W divided by mass, weight divided by mass. So newtons is the unit of weight, mass' unit is kilograms, therefore the unit of G is newtons per kilogram. 3 marks. Next is the core practical. Again, these are very important to know as they are more than likely going to feature in your real exam papers. 15% of every paper is a core practical in your exams. So this is a practical investigating the relationship between force, mass and acceleration. Newton's second law, F is equal to m times a. So let's start with investigating how force affects the acceleration of a trolley. So if you have a trolley down a ramp, you'll have these light gates. These light gates will measure its starting speed, its final speed, and the time it takes to travel between the gates. Hence, it will calculate its acceleration when it knows the final, starting, and the time it takes to go through it. How we vary the force on it is you will have a string attached to the trolley with a pulley at the end, and the forces will be acting here. You place all forces on the trolley, so all masses in this case. So let's say we place 3 masses, 1, 2, 3 on the trolley, and we place 1 overhanging here. Therefore, let's say this is a force of 1 Newton acting on the trolley. You let go of the trolley, it will pass through the light gates and it will measure its acceleration. Then you remove one of the masses here and put it on over the side again. So let's say we have 2 Newtons over the side now and only 2 masses left on the trolley. Therefore, it's going to have a greater force. Pull the trolley again, record the acceleration. Take the 3rd mass and place it over the pulley, and you've got a total of 3 Newtons now, and you let go of the trolley and it measures acceleration. Do that for a couple of masses hanging over it, so the force is always increasing on the trolley, and plot your data, you will get a straight line like this. This shows that if you increase the force on an object, its acceleration will always increase. And not only does it increase, because it's a straight line to the origin, you can see that it's actually a directly proportional relationship. That means that F is proportional to A. If I double the force, I double the acceleration. Triple the force, you triple the acceleration on the object. Hence, if we look at our formula, F is equal to m times A. If I increase the force on the object, I increase its acceleration. Next is to investigate how mass affects acceleration. Therefore, we need to keep the force on the trolley the same. So, if you set up the experiment again and place 1 mass on the trolley, have no pulley this time, just let it roll down the ramp itself, no pulley. So 1 mass on the trolley, let it roll down, measure its acceleration. Place a 2nd mass on the trolley, let it roll down and measure its acceleration. Put a 3rd mass, and so on and so on. You will get a graph that looks like this. This is not a directly proportional relationship, but it clearly does show that if the mass increases on the trolley, its acceleration decreases. Hence, F is equal to m times A. If I increase the mass on the trolley, its acceleration decreases, which makes much sense. Finally, circular motion. Before we can investigate circular motion, we need to remind ourselves of 2 variables, speed and velocity, and the difference between them. Speed, as we know, is a scalar quantity. That means it just has got size. Whereas velocity, as we know, is a vector quantity, as it has size and a direction. If we analyze an object moving in a circle, like the one here, we can clearly see that its speed is 5 meters per second, and that is not changing. It's a constant speed moving around the circle. However, its velocity is constantly changing. Why? Because if you look at it here, its direction is that way, and then when it gets to this point, its direction is that way. Therefore, its direction is constantly changing. And since velocity is a vector, it has a direction. its velocity is constantly changing, its speed is not changing, it's constant, because its speed is a scalar quantity. That is very important as to know how objects move in a circular motion. Let's look at a real-life example of a satellite orbiting Earth. As this satellite orbits Earth, we can clearly see that the speed of the satellite is constant. However, its velocity is changing for the reasons I've just stated, because its direction is changing. If its velocity is constantly changing, and we know that acceleration is a measure of how quick an object can change its velocity, that means that this satellite is accelerating because its velocity is changing. When an object moves in a circular motion like that, its velocity is changing and it's also accelerating. Also, there is a force that acts towards the center of the circle. In this case, the force is gravity. These forces have a special name and it's known as centripetal force. The centripetal force. It always acts towards the center. And in this example, because of the satellite orbiting Earth, the centripetal force is actually gravity. If that force was not there, the satellite would just drift out into outer space and it would not move in a circular motion. Other examples of centripetal forces are friction, which if you think of a car moving around a roundabout in a circle, the force that acts towards the center of the roundabout would be the friction between the car tires and the road. Tension, a hammer throw. A person who's swinging the hammer to let go of it, the rope that holds the hammer would provide a tension force which acts as a centripetal force towards the center. An electron orbiting the nucleus. When an electron spins around a nucleus, its electrostatic force, because electron is negative, if we think of a positive nucleus and the electron, which has a negative charge, spinning around the nucleus, the electrostatic force between the negative electron and the positive nucleus provides an electrostatic force which causes the electron to move in a circular motion. Let's look at an example of how they would assess you on circular motion. The figure shows an aircraft doing a circular loop. Draw arrows to show two forces acting on the airplane at point A and label your arrows with the name of each force. So, we know if anything moves in a circular motion, there is always a force acting towards the center, which is centripetal force. The other force acting on the plane would be the thrust force, which acts in this direction as the engines push it forward. Finally, explain what happens to the velocity of the aircraft between point A and B. 2 marks. Well, we know if something moves in a circular motion, it's traveling at a constant speed, but its velocity is changing. Why? Because its direction has changed. Therefore, that's the answer to the second one.